What is up, guys? It's Mr. Chap, and today I'm going to review you for your chemistry test tomorrow. We have our you got a paper review in class today. Make sure that you have that in front of you. If you don't, follow along, and this will still be a really good review. We have our periodic table right here, and we're going to answer some questions about it. So this is a Bohr model of an atom. You'll see that in the middle we have our protons and our neutrons, and on the outside we have our electrons. So let's answer some questions. Protons have a blank charge. Well, protons have a positive charge. So I'm just going to put a plus. Protons are positive. You can remember that with because they both start with P's. They have a positive charge, and they are located inside the nucleus. Neutrons are these O's, and they have a neutral charge, so I'm going to just write an O with a slash through it. They have no charge, and they are also located inside the nucleus. Electrons are the ones on the outside right there. They're minus signs. That means they have a negative charge. The way you remember this is movement of electrons is called electricity, and if you touch electricity, it hurts. It's a negative feeling, so it's a negative charge. And they are located in the electron cloud on the outside. So all these shells or orbitals. Okay, which two subatomic particles have the same mass? They are the ones that have weigh 1 AMU, and they are the protons and the neutrons. Which subatomic particle is too small to contribute to the mass of the atom? Those are the electrons. Are super small, and they weigh 1/2000th of the weight of the other ones, of neutrons and protons, and so those are the electrons. So electrons are super teeny tiny, and the protons and neutrons are much bigger. The electrons located on the outermost shell are called, and we're talking about this one, this one, this one, this one. They're on the outside, and those are called valence electrons. And that determines the atom's reactivity, whether or not it will combine with other atoms. Identity is determined by the protons and the atomic number, which is what you'll see on the periodic table. Let's see, beryllium here has an atomic number of 4. That means it has 4 protons. I can add neutrons, I can take away neutrons, and it's still beryllium. I can add electrons, I can take away electrons, it's still beryllium. But if I add or subtract any protons, it changes it. If I take away a proton, that number becomes a 3 now, and it's lithium. If I add a proton, that number becomes a 5, and it becomes boron. So protons determines the atom's identity. Reactivity, like we said, is determined by the number of electrons on the outside, called valence electrons. Alright, periodic table. All elements in the same group have the same number of blank, and all elements of the same, period, have the same number of blank, and all elements of the same group or family have the same number of blank. Just so that we remember, we have, these are periods right here, and they tell us the number of shells. I'll draw them out. And these are groups. Groups go up and down, periods go left and right. The groups tell me the number of valence electrons. Right there. Alright, so all elements in the same period have the same number of shells, also called orbitals. And all elements of the same group or family have the number of valence electrons. Elements in period 4 have, right there, period 4. So everything in this period, right there, this period, have the same number of shells. So they have 4 shells, or orbitals, or energy levels. They all mean the same thing. Elements in group 2 have the same number of valence electrons, and because it's in group 2, that 2 right there means it has 2 electrons on the outside. Elements in group 16, or 6A, right here, have the same number of valence electrons, and because it's a 6A, we have 6 valence electrons. Potassium is in period 4. How many shells or energy levels does it have? Super easy. It has 4. This is in period 4. Calcium is in period 4. How many energy levels does it have? Still 4. List 4 elements with 3 energy levels. So all you would do is you would find period 3, because it has 3 shells, 1, 2, 3, 4, 5. You can list any of those. I would say sodium, magnesium, aluminum, and silicon. Sodium, magnesium, aluminum, silicon. You could also say phosphorus, sulfur, chlorine, or argon, anything in that row. Tin has an atomic number of 50. Use 8-man and the periodic table to fill in the information for tin. So first we're going to look up tin. Tin is right there. Right there. So it has an atomic number of 50 and has an atomic mass of 118.71, and that 71 is going to round to 119. So 50 and 119. So as atomic number of 50 and atomic mass of 119. Double check to make sure. Yep. Alright, so what we're going to do first is we're going to use 8th man. A equals P equals E. And my A is my atomic mass, or my atomic number, right there. And that's 50. And because I have 50, in this class I have 50 protons and 50 electrons. So I know this one, 50, and I know this one, 50. We need to calculate the number of neutrons. To calculate the number of neutrons, I use man. M minus A equals N. My M is 119. My A is 50. And so my number of neutrons is, what was that, 69? 69. Okay, groups and periods. We're going to look at periodic table. 10 is right there. It's in period 5 and group 4A. Period 5 and group 4A, or 14. That means it has 4 valence electrons and 5 shells. We know that by the number, the period, and the group. Is it a metal, a non-metal, or metalloid? We're going to look at it. And anything to the left is a metal, so we have a lot of metals. Anything to the right is a metalloid. anything touching the stairs, or most of them touching the stairs, are metalloids. Sorry, I think I said that wrong. Metals, non-metals, anything touching the stairs is metalloids. So tin is right here, and it is not touching the stairs, and it is on the left side, so we're going to call that a metal. Let's see, rubidium has an atomic number of 37. Use 8-man and the periodic table of elements to fill out the information, so let's find it on here. Rubidium is right there, as an atomic number of 37 and an atomic mass of 85.4. There's a 0.4 there because that is not 5 or more. We just let it rest, so it rounds to 85. So 37 and 85. So we do ape. A equals P equals E. 37 equals 37 equals 37. That means we have 37 protons, 37 electrons. M minus A equals N. That means we have 85 minus 37 equals, I don't want to get it wrong for you guys, 85 minus 37 equals 48. So I have 37 protons, 37 electrons, and 48 neutrons. It is in group 1A and is in period 5. 1A, period 5. Because it is in group 1A, it has 1 valence electron, and it has, because it's in period 5, it has 5 shells. It is on the left side of the periodic table, and so it is a metal.
we're doing it together.
Yeah.
We're gonna do the second part tomorrow.
You say you're going to do the second part tomorrow?
Ain't no way.
Did they say he's going to do the second part of the review tomorrow? Are we moving? Oh, okay. So, like, they give them the benefit of getting that. Yeah, those give you the answers. We're like way back.
Oh, I also want to show y'all what we're doing today for the practice.
Well, please talk to her because she's going to be quick.
Yeah, right.
I was trying to talk to my colleague and I was hoping to address that.
I found
I didn't get to talk to this morning that duty.
What happened?
Giving Mr. Chancellor a hard time.
I'll be down there.
I'm recording my thing.
Yeah, go ahead. All right.
You know what I mean with this recording stuff?
I have most of it.
Oh, yeah?
Yeah.
All right, so here it says element R is pictured to the left. Fill in the information below for element R. So this is a very, like, kind of bare bones Bohr model, but you can still tell a lot of information from it. First of all, you can tell the atomic number. You can tell the atomic number because the atomic number is given to you by the number of protons, and it says we have 12 protons. So my atomic number is going to be 12. We can tell the number of protons because my atomic number is 12. Valence electrons. Valence electrons are the ones located on the very outside, here and here. So we have 2 valence electrons. And from that, we can figure out what group it's in, because it's 2A, because we have the number of valence electrons. But how would we figure out the number period, the period that's in? We would look at the number of shells. So the number of shells is 1, 2, 3. So it's in period 3. And just for bonus, we can figure out what element this is by looking at atomic number 12. Atomic number 12 is right there, Mg, and let's verify that we got that right. It's in group 2A, and it's in period 3. Looks good. We can do the same thing here. Atomic number is that number right there, 20. That means we have 20 protons. Number of valence electrons, the ones on the outside. We have 2 valence electrons. That means it's in group 2. To figure out the period, we count the shells. 1, 2, 3, 4. If you want to figure out what element Q is, look on the periodic table. Find number 20 right there. It's calcium. We were right. 4, period 4, group 2. Okay. Use the Bohr models on the right to fill in the information below. So we have our Bohr models here. That says sodium, that says chlorine, that says gallium, that says tin. How many valence electrons does neon have? Oh, wait, never mind. That says neon right there. we're going to look at the outside. 1, 2, 3, 4, 5, 6, 7, 8. How many valence electrons does chlorine have? 1, 2, 3, 4, 5, 6, 7. How many valence electrons does gallium have? 1, 2, 3. How many valence electrons does tin have? 1, 2, 3, 4. Out of these 4 atoms, which one is the most reactive and why? Well, reactivity is shown by the valence electrons, which is why we list all the valence electrons. And in this class, we said that if we have, if your atom is in group 1 or group 7A, 1A or 7A, that means you have 1 or 7 valence electrons. It is highly reactive. If it's in group 8A, it's not reactive. Anything else is just somewhat reactive. So we're looking for 7. 1 is either in group 1A or 7A, so it's highly reactive. So I'm going to say that chlorine, and then I'm going to say it is in group 7A. That means that it only needs 1 more valence electron, and so that it can get that pretty easily, so it reacts pretty quickly. Out of these atoms, which is the least reactive and why? So we learned that group 8A are the noble gases. They have a full valence shell. They have full valence shell, so they don't react with anybody. And so neon is stable because it has a full valence shell. All right. Subscripts versus coefficients. So we can look at like this right here as an example. 2C6H12O6. The big number, that number right there, tells you the number of molecules, and it's called, these are called the coefficients. Spelled right there. The small number tells you the number of atoms, which are called subscripts, which is these numbers right here. All right. Count the number of atoms in each of these. So first thing I tell you to do is cover up the coefficient if there's a coefficient. There's no coefficient, so I don't have to cover it up. Then we underline the capital letters, C, H, O. And those are done for you, C, H, and O. These subscripts tell you how many atoms there are. So carbon has 2. Hydrogen has 6. Oxygen has no subscript, and in this class we say none means 1. So there's no subscript, so that means there's 1 oxygen. All right. We're going to do the same thing over here. A, Al. Well, it's not working at the angle. Al, S, and O. So we have those there. Al has a subscript of 2. S has no subscript, so none means 1. O has a subscript of 4. And in this parentheses, that 3 only applies to things that are inside the parentheses. So Al is not in the parentheses, we skip it. S is inside the parentheses, so we multiply that by 3. That means 3. O is inside the parentheses, so we multiply that by 3. And we have 12. All right, this one is slightly different. Kind of looks like that, but there's something a little different about here. We have we have C there and C there, and we have 1 C and another C. So we're going to add those together. So we have 2 C's. We have 3 H's. And we have 2 H's, and we add those together. And we have 5 H's. We have only 1 Br. So we have 1 bromine. This one's pretty easy. C, H, O. We have 4 C's, 10 H's, and None means 1, so 1O. Right here, all we do is we have a coefficient, so we cover up that 2. We underline our capital letters. We have C, H, and O. We have 6 C's. We have 12 H's, and we have 6 O's. Now we lift up our finger, and we multiply everything by that coefficient. So 6 times 2 is 12. 12 times 2 is 24. 6 times 2 is 12. So the things they might ask here are how many elements are there? And if you ask how many elements there are, there's 1, 2, 3, all the capital letters. If they ask how many atoms of oxygen there are, you would use this number. There are 12 atoms of oxygen. And if they ask you how many total atoms there are, you would add all of those together. 12 plus 24 plus 12 give me 48 total atoms. It just really depends on what they're asking. So pay close attention to the actual question. All right. So that is the entire review. That should really help you out on the test tomorrow, hopefully. Make sure that you're ready. Make sure that when you get this periodic table, you do your brain dumping. You can do your 8-man up here. You can do your Bohr model. You can circle these. You can circle the valence electrons. You can write 1 and 7A are highly reactive. So good luck, guys.